Oh, microphone was on. Whoops. Well, I guess that's hello, everyone. So let's start. So yesterday we had a relatively short hour and a half, but earlier stream. Part of it just because I had to finish something. I'm like, well, let's just, instead of doing something else, stopping and doing this, and then stopping and going back to that, let's just, do this, and then after we're done, do the other thing. So the other thing being some animation work that I'm working on for my actual job, even though it didn't exactly get much accomplished last night, but it's not important. Let's have it be Team 3. Let's have that be Team 4. I think that'd be blue versus red at that point. Blood red, yeah. And right now the AI chooses to give up its turn. Which appears instantaneous because it's not actually getting delayed for the animation of the piece. Anyway, so let's continue. So we have here a simple is positive trade function. And that will tell us whether it's just one move out, whether it's gonna be our favor or not. So whether the lowest piece that can kill our piece wherever it moves is where the lowest piece that can eat our piece is higher value than the piece that we're sending out. Assuming, of course, there is another piece that can guard that space. If not, it's always going to return -1. Once we remove the instigator, of course, because the instigator can't defend itself. Let's see here. I don't care about any of those. Okay. Can we dismiss? Oh, there's dismiss there. For some reason it doesn't want me to log in, but anyway. So there's that. Okay. So now we do select move. And when begin AI happens, select move will be whichever move is index from all moves. And if it's invalid, so it's not, it's either, oh! Someone mentioned I just went live on Twitch, which is nice of them. Now we're gonna need another another function. So float is positive trade recurse or sum. A piece instigator fint vector location. So we're going to do similar to what is positive trait simple can do. We're going to also shrink the output window substantially so we have more vertical room to do something like this. So we will create a declaration. And IntelliSense is going to push it in to this C++ file. I'll close this peak because I don't care, because we're instead going to have it here. And now we can move this over. So again, these are two views into the same same file, just different parts of it. Okay, so so probably have multiple of these because we may want. The reason we're having multiple functions instead of one function is everything is because we're probably going to want to have different views in the same data. So the positive trait simple tells us whether the one move we have is going to be in our favor or not. The sum will follow all of those and give us a value. The problem is when we get a value, it's very useful if we want to see, over long times, if you have positive values and you keep making positive values, you're going to continue winning. You're just going to win because you're always making positive traits. But the problem is it doesn't tell us anything about individual steps. So for example, let's say we have an entire chain of eats be positive in our favor, but it takes a positive and then a bunch of negatives and then a positive trait at the end, and that positive trait at the end is worth all the negatives. Well, if they just do like 4 of those 5 steps and then make sure we can't eat the last one because they move it out of the way or whatever, then it's negative in our way, right? So we want to have different views into that. So we kind of weigh like, if the entire chain goes as it seems to, because we're not... It's easier in some games of chess, like you see some games of chess on like Flash games or whatever, they force you to eat any piece. If you can eat a piece, you must eat a piece. But some other games of chess, I'm not sure, what is actually the official rule of chess when it comes to forced eats? Because there are some slight variations. So I'm looking at a page right now. Capture is not obligatory in chess. There is one case where everyone's capture, king is in check, and the only possible is to left to check is to capture. In other cases, the player can decide whether or not to capture. There are some games of chess where they force you to capture. In those cases, then you can assume that the entire chain must occur. So the official rules of chess, apparently, according to this guy, they actually say guy, girl. They do not. Oh, they do. Written by Hans, but yeah, so guy. The guy's name's Hans. Anyway, so apparently the official rule, according to this guy, is that you do not need to capture, which is good. And that's kind of what I was hoping for anyway, because forcing the opponent to make a move that's not beneficial, it just removes that strategy from it, right? It removes a choice from them. It gives you the way of forcing people to make plays, so there's some strategy in that sense. But yeah, I don't really like that thought. And also, even then, it's a bit more complicated to implement. You have to physically implement it, depending on how you set it up, of course. For the way I have it right now, where we just kind of get all possible moves, and as long as it validates, it's fine. But I assume there's probably some ways you can set up the movement structure such that it's easier to force capture than not. That would depend probably on how you set up your capture. But anyway, that's hypothetical for other programmed games than us. But anyway, so that aside, we can, yeah, so we're not forcing people to capture, so yeah, there's that. So we need to then account in the AI for how to see into the data we have such that we don't make stupid mistakes assuming that a future move will occur when it doesn't, right? And even that could be a problem if you have multiple players, because a third player can intervene, or a fourth player or fifth, right, could intervene, and that could screw up your chain. However, it's still good to calculate what the end of the chain will be, so we'll need multiple functions to view into that. So that's why I decided to do it in multiple functions. Someone who actually is, experienced in programming AI might be like, right? But yeah. So potential pieces. Oh, am I doing this one over here? I don't need to do is has cover because B has cover because or should I? Okay, so I'm guessing I should, but not in that way, because the problem is I need to keep recursing, right? I need to keep going until one side's out of pieces. So, yeah. And this will be slightly off if there's 3 or more people involved, because I'm assuming in the way it's set up, it's me, then them, me, then them, me, then them, me, then them, where it's entirely possible that there could be 3 people all free-for-all, right? Such that there'll be multiple captures in a single round, but still. This will probably be done on per turn basis anyway, so after the first turn, the state will update and we'll be like, oh, this is not a good assumption anymore. Or rather, we'll forget the original assumption, calculate it then, and like, oh, this kind of sucks. Why are we here? Let's go back, right? So is positive trade sum. 4. Actually, a while loop would make more sense for this. So while either side still has a covering piece. So we get the name of we get the list of all the pieces. We'll do bool b. Well, loops are a bit dangerous, of course, because if you forget to terminate them, or you have a condition where they don't terminate, they'll keep going forever, right? So you have to make sure that they recurse down to a value. So while B still covering, to be running. While be running. Bool b enemy turn equals true. So what we're going to have with this one is a flip flop between I capture, they capture, etc. Thanks, Mer. So while be running so bool B has cover equals false, and then I'll just copy and paste this crap, because if this works once, it'll work again. Okay, so I want to do a flip-flop, so B has cover is false. Here. B enemy turn and or B enemy turn is false, so we're gonna start with ours. Oh, and one more thing we need to do as well is we also need to see if there any piece at that location already. Equals base game states. So while we fix this, we're going to come on, there we are. So while we fix this, we're going to in the one we did yesterday, we're going to I'll have that. Get piece at coordinate. There we are. Or game state. In32 instigator, or sorry, target team equals. Actually, we need target team. I actually need target value. Because again, I'm going to be assuming that everyone's against me that's not on my team. Team including my allies, so. Equals 0. And then if target value equals target piece value. So we're going to be avoiding this null pointer if we do that. Otherwise, it'll just end up being 0 still. If no one has cover, then we'll do if instigator value is less than or equals target value, return 0, else if instigator value is greater than target, or less than target value. Otherwise, we'll be getting the lowest value piece. Because we can still make a positive trade if we kill something in that time. We were kind of implicitly assuming that the piece would be, or the tile would be empty. Oh, no, I'm going to need it as well. Actually, no, I'm not going to need to, because we're not going to have a valid move if it's a friendly piece. I was going to compare teams, but we can't move there, so we would never compare there. Okay. Now I'll do explicit else. I don't need to, I can just have it be blank off, but you know. Okay, now we'll do that split again. So now we're back to where we were. Okay, so, wow, this is all messed up. Solved it. So I'll be running, so we're going to keep recursing this and sum it up. Float total value equals 0. Maybe I can just do it by hand at this point. As in without looking up. Okay, so total value is 0, potential piece is there, blah blah blah. While running true, so we'll have at least one run in. B, enemy turn is false. So the first one will be if we're going to be killing anything. Actually, no, we should do true. Because we'll do the first thing earlier. So if target piece value, let's have so total value plus equals. There we are. So we're taking the
I just gotta know one thing.
We're taking the first eat that we have and we're adding it to it. So now we're going to have the enemy turn and they can capture us back. So if enemy turn is true, has cover is false. Bool. So I'm trying to think of the Boolean math for this. So what I want to have happen is, if it's the enemy team, I want this to evaluate if this is false. Oh, okay. So bool bool B is my team. That'll work. Bool be my team equals current piece team equals instigator team. So whether if this value is true, it'll be my team. If it's false, then it'll value false. So we'll do if B enemy turn doesn't equal be my team. So now we'll have B has cover. So now we'll have whatever team it is, whether they have cover by flipping. Okay, so all that. So now we know if there's cover. So if B has cover, we then need to loop through all of the pieces. Hi, welcome to the chat. And then currently piece team. Oh, oops. So before it was if they are, now it was if they aren't, I believe. So we want it to be the other way around now. So before if it wasn't, now we do if they are. The enemy term. Equals B currently instigator team. Well then, current value. Okay, so B has cover. After this, we will then do total value if B enemy turn total value minus equals min value, else total value plus equals min value. And then we will need to remove that piece from the list. So potential pieces that remove. So we'll do if doesn't have cover, and we'll do else here. Will we be running equals false? So we'll keep going until they don't have cover. And then after all of that, we will return total value. That's gonna be a pain in the butt to test without a test level specifically for it. That's okay. First, we're gonna see if it even compiles. So build succeeded, that's good. So now we'll do base player controller. Oh, I can't even do that because I have to do it on the AI thread. Shit. I was gonna say I could just call the player controller to do that, but so it keeps flipping and flopping. So then after this loop, or after, so after this whole loop, we'll do B enemy turn equals not B enemy turn. So we're flipping each time. Oh wait, that's not why being within the while loop. Oops. There we are. Issue doesn't account for 3+ players. Teams. Neglecting because calculate every turn. And really what they're going to do is, if it does get captured, they'll kill the other team's piece, so it doesn't really matter for us necessarily. downestimating, underestimating. Okay. Let's get build. So we're this is a trade simple, this is a trade sum. That'll be good for now. Okay, so let's go back to our main calculation function. So for int 32 I equals 0, I less than possible moves.num I plus plus. We will oh gosh, a piece instigator equals possible moves because I think all it gives me is start, destination, and type. Start, destination, and type, yeah. Oh, cool, thanks. Yeah, I'll make a note of that. Mer PPC asked to listen to Fallout 4 remix. Link in hex chats. So I'll make a note of that. Obviously, I won't play it on the stream because, you know, for copyright issues, but yep. Anyway, let's back to this. So game state. Come on, you. Cool. So I made a note of it to see it after. I say that because last time I said it and I forgot. F move token, current move equals possible moves I. Current move. Dots. Start. Cool. Okay, so we're getting the instigator piece. If instigator continue yeah, it's create comments and stuff like that, but just in case for YouTube, Like, there's even one time that Monster Cat, the people I pay for the license, has hit me with a copyright notice. So, I mean, I contacted his support and they removed it, but it's like, I try to keep as much away from it because it's just a bother, right? Accidents happen. And also, sometimes they do something in Creative Commons, but they don't have the rights to do that. The person who owns the rights will then get me. So, like, for matchups and stuff like that, they may be fair use, but the original owner might still go after people anyway, even though it was using a fair use version of that, right? I'm a bit, paranoid of it, but yeah. Anyway, so, so how do I want to treat it? Yep. See how each move affects eating, capturing trades. Switch lag isn't kind of intense tonight? Okay. So yesterday, and I don't know how this would work. Oh, the lag. Yeah. No. So I don't know how this would work, but the last time I was on stream, people had some buffering issues, and one person suggested adding a delay in OBS. So I'm adding a 10-second delay. I don't know how that would actually affect anything, because all it does is sends the video on my end delayed to Twitch. You wouldn't think that, like, if they're gonna have a lag bubble, they'll just have a lag bubble that should be 10 seconds back. But they said that for some reason that would actually give them more time. I don't see how that would work, but apparently it does. So they say. So I'm actually going to keep, I'm going to ask about it, because it seems the feature in OBS should be there for people who are, for example, playing Dota or League of Legends or StarCraft, and they don't want people to play against them and look on Twitch to see what they're doing, especially if it's a tournament, right? Where if they're having an offline tournament for like IEM or something, and then one competitor is just looking at the other competitor's screen like, oh, they're going to DT rush me. Okay, then. Yeah, talk to Ven about that. I can talk to a bunch of people, probably the OBS people. They might know best. They're on Freenode as well. I mean, Ven might know, but the developers are on IRC all the time, so I'll just ask the developers, right? Haven't got around to it yet, so I've been leaving it on just in case, but if it ends up helping stuttering a little bit, then okay, sure, why not? But I doubt it, but they said it was, and then they said it worked better for them. They could have been screwing with me, they could, be noticing it more now that they think it's been fixed or whatever, I don't know. Or it could be legit, I don't know. So, we'll see.
After they came and destroyed the land, there was one
in 32,
for all of mankind.
simple trade equals is positive trade simple, instigator, and current move dot destination. Alright, welcome to the chat. So now how do we want to treat this? So, you know what? Let's do it like this. So we'll do a T-Ray, int32, positive trades equals positive trades, T array in 32. Oops, what are you doing? Equal trades, T array in 32, negative trades. What IRC channel am I on right now? I am not on any IRC channel. Well, I shouldn't say that. I have a list of several of them open. I'm on Mozilla server, Twitch server, PC Perspective server, Freenode, and also Twitch as well uses IRC. Right now, all I'm monitoring is the Twitch IRC, or the my channel for Twitch. Although someone in PC Perspective tried to contact me. Oh, they're saying I'm on. Okay. But there's also later on I could go to OBS's IRC channel on Freenode. I think it's Freenode. I'll have to look it up. It's on their website. I've been there a few times. If simple trade equals is greater than 0, positive trades dot add I, else if simple trade is equal 0, equal trades dot add I, else equal or negative trades dot add I. So this loop through all our possible moves, we're going to get a simple list and create 3 lists out of it. So we'll sort them into positive trades, equal trades, and negative trades. In the vast majority of time, positive trades will be none, negative trades will be none, equal trades will be all of the moves because we'll just be moving around the board. But in high combat scenarios, they'll start fanning out. So we're still keeping a list of all possible moves. We're just sorting them into ones that should be positive, one that should be equal, and one that should be negative. Now we need to think of what we want to do with that. So, this is going to be a bit of a pain in the butt to debug as well. We'll have to keep a breakpoint on the debug thread and just every move see it break and step through. Good. So now we have a simple trade. We'll know that whether one move ahead, whether we're going to be eating something that's more valuable than what we're sending out to eat, doing an equal trade, or a not equal eating. So and it's possible that it could be all negative trades if for some reason we end up having all possible moves ends up getting eaten. But these will probably be bottom of the barrel. Right. Oh, whatever. I'll deal with that later. I was going to say I can go back into check it types and redefine is valid to be more than just, you know, finding out whether it's a -1 move. Actually have some logic behind it, but that's not something I really want to do right now. Now we have 3 lists, or sorry, sort moves into one of the 3 lists above. So now what do we do? Do we want to have it always take a positive trade as an easy one, or do we want to have a bit more logic than that? Oh, we can get sides of teams. Right. Okay, so riboflavins, what we're doing at the moment, just because the, oh, thanks for a good evening. What we're doing at the moment for this is we're going to assume, okay, so basically how it's right now, we were kind of screwed up a little bit in how we can recurse ahead in moves. So the logic we're using right now, we're kind of see how it works, is we will only recurse through eats or captures. So potential captures. So for regular like moves where no one gets eaten, we will only look 1 ahead. Sort of. But in the event that there's a capture chain where I can eat, then they can eat, then I can eat, then they can eat, then I can eat, then they can eat, we'll follow that through until one side's out. With this function right here. Whereas this function only does 1, where it says, can I get responded? And it checks to see the response for the lowest value. Because we're going to assume that if the opponent can eat my, or capture my piece, and that piece will get captured again, they're probably going to send their lowest value one out, right? So if they can have a queen and a pawn that can kill my rook that's guarded by a knight, they're going to send the pawn to die, not the queen that will be then killed by the rook, right? By the knight, right? So yeah. Rook moves, pawn eats rook, knight eats pawn, queen eats knight, versus, you know, rook moves, queen eats knight, knight eats queen, pawn eats, they lose, right? Okay. Yeah, yesterday I did it a bit quick because, well, basically I was done doing stuff at like 7:30. And I could have started another thing for an hour and a half and then stopped and then started again afterwards, but I decided just, you know, do the stream early. Because now we have the positive moves. So we're basically just sorting data at this point. I mean, honestly, all of programming is just translating data. That's all programming ever actually is. some translations are not very obvious. So if you look at a person, you're like, oh, you're doing some magical stuff. Like, no, you're just translating data. It could be mouse clicks into video, or it could be, you know, keyboard to whatever, or network communications to sound or whatever. But it's really just a communication. So how a game works, for example, is you have install media or Steam payload that gets installed to your hard drive. That's a bunch of data and some code. The data is 3D models, it's sound files, it's whatever. When you start a game, the data on your hard drive will be translated into, by using the code that comes with it, it'll be translated into video and audio and network communications if it's multiplayer, based on the mouse and keyboard input that is, or controller input or whatever you use, and network communications that you receive and send. So it translates stored data and mouse clicks and keyboard into video, audio, and network communications. Stored data, mouse, keyboard, and network communications into video, audio, and network communications. And that just keeps looping over and over and over again. But it's all translation of data, right? So what we're doing right now is we're translating data into something that might be useful for AI based on what we think ahead. We are not very good at AI because I don't have formal training in it. I only did like a little bit before, mostly just for a 2014 version of Check It. So we'll see whether this translation will end up being something that's fun. But all we're doing right now is we're translating data into whatever it is. So we're translating right now data into trades that are positive, trades that are equal, trades that are negative, and then we're going to keep seeing further beyond that. I know I'm repeating myself a lot for people who are watching YouTube, but people drop in and out of the Twitch stream, so try to keep it useful. Okay, so now what we're going to need to do is so one thing I would want is to get a value totaled on a move-by-move basis so we can see whether, so we get the sum going forward. I want to see whether the sum over 2 moves, over 3 moves, over 4 moves will be any different. I'm not sure how it would end. Well, I know how I would do that. To get that value, I would take the thing I just programmed for positive trade sum, duplicate that, but also add an extra integer that counts down each time the swap occurs. So each time PPC actually yesterday, because I started early, I was actually done by Linux Gamecast start time. I stopped at 9:30 Eastern. So I was watching Linux Gamecast with y'all. But yeah, it's all on YouTube, so yeah, I put yesterday's on YouTube. I didn't forget. I know I had to stop and do something first, but yeah, I remembered eventually. Anyway. Part of me just wants to be like, if there's a positive trade, do it. And see how good that is, but you know what, we'll see how good it is for now. Let's just do so fix me, because I know this is not going to be good, but you know what, it'll give us a benchmark of something we can do. So if positive trades.num is greater than 0, so if we have more, or .num function, I'm used to JavaScript again, where num is an actual value that's constantly updated. Although making the function makes more sense because otherwise you need to constantly update it every time someone needs it. Whereas if you call a function, then the act of observing updates it. So you don't need to constantly do useless updates each time, right? Which, I mean, useless updates could be, in JavaScript's case, easy because the act of modifying it could adjust it. So each time you poke it, because it's not going to just poke on itself, right? You have to poke it each time, and each time it's been poked, you can decrement it. Yeah. C++ probably doesn't have a very good option for that, especially since they have direct memory access to it. Because the last thing you want to do is have someone directly access the memory of this and then assume that it's a number, but the value inside gets screwed up. Anyway. Well, you kind of had direct memory access by using void pointers. Anyway. Right, so if pository the number equals 0, we're going to float max trade equals 0. We'll do -1, even though it should never be 0, because otherwise that would have been sorted up here. int32 max trade index equals the -1. For int32 I equals 0, I less than positive trades dot num I plus plus. If so we're gonna get the f move token current move equals possible moves I, or possible moves we'll do int32 current move index equals positive trades I, possible moves current move intex, and then we will have float current trade. This sounds such like a Enya song. I keep hearing it, but I never think, so scroll it down. Keep hearing it, but I never think to look up this name whenever it comes on. Current trade equals is trade positive trade sum. Current move. Oh right, I need to do current move dot destination. So what did I do for that? Okay. Current trade is that. Then we'll do if current trade is greater than max trade, equals current trade, and max trade index equals current index. Then we'll do outputs. Sorry, return. We'll do output. No, we'll do return output. Output equals max trade index. Return output. Happen to see 1080s in stock at Canadian retailer. Checked a couple times out of curiosity, but it's been backward everywhere I looked. At the moment, no. On launch day, I did. On launch day, it lasted till around 8 o'clock at night, 7 o'clock at night. There was still stock of one single EVGA that was on for $8.99 Canadian, which is about $100 more than what it should be for the $6.99 trade-off, but you know, gouger's gonna gouge, right? That's all you can say. If even trades? Trades. Greater than 0. Was looking at graphics cards today, sticking with my GTX 670. Oh, I can't even do this. So what I was doing was, if equal trades that were grabbing the one with the best equal trade. But that we need to do pathfinding. So, okay, so positive trades, equal trades, and negative trades is how I separate moves based on whether the move itself will, with one recursion, lead to a higher value grabbed than higher value lost, right? Actually, I think I screwed up a little bit. Or no, I didn't. Yeah, no, it's fine. So equal trades is either no one's getting eaten, or I send a pawn, they eat a pawn. I send a queen, they eat a queen. Sorry. I send a queen, they eat my queen with a queen, and I kill the queen. Or they send a pawn, they eat the pawn with a pawn, you know, and so forth. Or I send a, you know, a rook. and they kill the rook. Sorry, they can kill the rook with at least another rook, another bishop, or a knight. Sorry, another rook, a bishop, or a knight. So I can then, and I have a cover to kill it, right? Did I say all the values for pieces? For now, what we're gonna try is a pawn's 100, which is, you know, standard 100%. Knight, rook, and bishop are 300. Queen is 600, I believe, and king is 700. I think that's right. King is 700, yeah. So if equal trades.num is greater than 0, so we need to fix me add pathfinding here. What was math rand again? What was our random range equal moves.num. Return sorry, yeah. Output equals max trade index, or output equals selected move. Return output. Currently select. Why is this visible? Equal trades. Whoops. So the game's gonna play randomly. But if it can eat, it will eat. If it can eat a positive trade, it will eat. So if I put a pawn up to a king that's covered by another and the pawn's covered by a knight or something, it won't take that trade, or it shouldn't take that trade. But if it is, then yeah. And otherwise, ignore negative trades for now. Just skip turn. Okay, that should be good. So now we should build, and this means that if we give it any favorable trade, the AI should eat it no problem. And eventually I'll add some debugging characteristics to it, but you know, like logging and stuff like that, so I can see what's actually going on through his head. But for now, we're just gonna see if I give it a move where it can kill me, if it'll do it every time. So I'm gonna be losing a lot for this little bit, so that's fine. So it chose a random move. There, okay. Wait a minute. Oh, it went laterally, okay. So, you're gonna die. That wasn't a possible move because there was no king nearby. Now let's see. It's choosing another move at random. It's moving its king up. Cool, cool. So So now I gotta be careful because it's going to want to kill crap, right? So I'm gonna cover the pawn with a king. Because the pawn's a very low value piece, so if it's stuck. It's stuck somehow, huh? It can't be randomly choosing it that many times. There's something wrong. There's plenty of other moves it can choose. So I'm going to... Oh, the knight will kill it there. Yeah, the AI is broken, I know that. Gonna see why it continually wants to go back and forth. First, I need to draw this out, which is probably good because I'm then not trying to... So it should not take it until I do this. And it should take that piece. No, it didn't. This AI is just stuck. It should take the capture, but it's not. Well, let's close this down. Let's set up, run with debugging. And we will see what it's trying to do. Before I do that, let's see here.
Starlight, the innocent lifetime flickers and flashes under a canvas. No, nobody seems worth it. While the feelings
It's we're gonna have to step through this at some point. So I'm going to get closer to that situation where we just had, but I'm not gonna debug each time because I don't really care what the AI is thinking until I have a pawn that's within capture range. 2 GB RAM usage for Unreal Engine? Yeah. With debugging? Yeah. Remember, this is running a full Unreal Engine version, right? I mean, I could set up a test level such that this would be easy, but so that everything's always set up by the time I get there. Like, first move would have the bad case already set up. Because what I should see is the AI trying to do random bullcrap. That makes no sense. Huh. Okay. Well, it wins. I wasn't thinking of the queen. Oh well. Okay, now I actually am running when that breakpoint is. So turns team is 0. Turn team is negative. So it's a race condition, clearly, because it doesn't happen every time, and that time I'm pretty sure I had. Yeah. So rounds starting. Current player pieces. So teams invalid. Why are you creating so many damn teams? Okay. I still don't know what's going on with that. Hey, welcome to the chat. Okay, so we'll kill that. Go up here. So we're gonna approach it from the far side so the queen won't ever be in range of us. The problem is I can make a test map for this now where this situation is already set up. or well, rather just adjust the test map so it's always set up. But I don't know if adjusting the test map will cause it to the error to be circumvented, right? Stay within the last 4, I think it is. Oh, last 6. I'll be fine. Because I'll be out of the range of the queen being able to attack me. I'll do the last 3 though, because the king is not exactly symmetric from one side to the other. I'll do the last 2 just in case. So when I need to come back, I need to come back at the last couple there. Okay. Just gonna do it with the controller so it's a bit easier on my fingers. And then I guess if I don't know that making it start up there will cause the issue to occur, I don't even know if moving it by hand will cause the issue to be circumvented either, so. Sure, I'll make it like this, then I'll make it like that, then I'll make it like that, then I'll make it like this. And now I'm gonna call a breakpoint on AI runnable for begin AI. Start down here and we'll step through. Okay. So we're gonna shut down the controller. So selected move is step into it. Excuse me. Step out of that. Okay, so selected move was 1. What was? What moves? Move 204. Oh right, I did say yeah, it's not said. So it looks like it's moving the king back. Excuse me? Hello? King, I'm afraid that's not a valid move. We got Neo up in here. So it seems to think that... Okay. It's making stupid trades. Okay. Right. So, we've learned that all of this is broken on several levels. So we'll fix it next time. Thanks for watching, everyone.